Hi everyone. Let's go with gaseous state numericals. Okay. States of matter, gaseous states of matter, whatever you talk about, the numericals based on that. So the very basically, I'm not going much deeper anything into your theory part of it because theory we have already discussed. So let me go with a quick relation. P1 V1 by N1 T1 equals to P2 V2 by N2 T2. This is one such equation which helps you out most of the times. And the ideal gas equation. And what's your ideal gas equation? PV equals to nRT. PV equals to nRT. And moreover, if you are asked about the density, how do we bring out the density? Pressure is equal. Now, what is density? Density is mass by volume. Now, pressure is equal to N by V RT. N stands for the number of moles given mass by molar mass into V and RT here. Now I want mass by volume. This is my mass by volume. This is my density. Density is equal to P times molar mass by RT. Density is equal to PM by RT. That is one other formula which you will generally look for, which you will be generally using for. Now let us start about 1A of your exercise in your base material. Right. So 1A exercise, let's start with it. Number one, question number one. You're given an isotherm. Now, what is an isotherm? Isotherm is at constant temperature. You are given some cases at constant temperature. This is pressure and volume. So at constant temperature, how are your pressure and volume related? And some things here are given to you. This is 1, this is 2, and this is 3. So now there are a few options here given to you. Is T1 is equal to T2 is equal to T3, or what is the relation between T1, T2, and T3? This is T1, I say. This is T2, I say, and this is T3, I say. So how do we go with? Let me take something as a constant pressure, and here are my V1, V2, and V3 correspondingly. Okay, this becomes my V3 here, this becomes my V2 here, this becomes my V1 here, corresponding to T1, whatever I get, that is V1, corresponding to T2, whatever I get, that is V2, corresponding to T3, whatever I get here is V3. And I know PV equals to nRT is my ideal gas equation. Here, I am putting my pressure constant. See, pressure is constant in 3 cases. Pressure is constant. N and R anyway constant. Now I have to talk about the relation between V and T. V and T are directly proportional to each other, which means here my V3 is least, V3 is less than V1, V2 is less than V1, and I have my direct relation with temperature as well. So therefore, T3 is less than T2 is less than T1. Which means I have an option here stating T1 is greater than T2 is greater than T3. Option C will be your correct answer for this. All right. So this would be your first question. Then moving on to the next one. Yeah. Question number 2. Here talking about the volume of a largely irregular shaped tank is determined as follows. The tank is first evacuated. Matlab, it's an empty tank. It's an empty tank and then it is connected to a 50-liter cylinder. See, as I'm reading out your question, I am drawing my information. I'm putting in my information. Try to put it that way so that you will understand easily what is that you have and what is that you have to bring out, what is that you want. Right. So now it is being evacuated. This tank initially empty. Initially empty tank. Please write it down as it is in your notebooks so that you would go with a recap very easily then. Now, initially the tank is empty, first evacuated, then connected to a 50-liter cylinder, compressed helium gas. This is your helium gas here. Okay, now the gas pressure in the cylinder originally at, this is originally at 21 atm atmospheres. Now, finally, how much is that? 7 atm given to us. Originally, it was at 21 atm atmospheres and now at 7 atm without a change in temperature. Temperature here is constant. Temperature is equal to temperature here. What is the volume of the tank what is the volume of the tank here asked to us. So now volume of the gas is nothing but the volume of the container which we are using, right? So that is what we have to look for. Volume of the gas is always equal to the volume of the container. Now, what is that given to us? We don't know the volume of this. Let me not, go with any guesses and also let me take that as volume V only. So originally, what is that we had? Originally, it was at 21 temperature. Okay, and it was at, not temperature, sorry. Originally, it was at 21 atm, and we don't know the volume of the gas, what it is inside. Now, the 50 liters, I brought the cylinder and I have attached it here. Now, my atmospheric pressure, now my pressure in the cylinder has become atm, 7 atm now. Okay, in this case, what will be the volume? Volume will be 50 ml plus the V here, right? 50 plus V here, and here it is 50. Right. So now 21 at 21 atmospheres, 50 liters, whatever it is, I'm connecting it to another big tank, which is of the volume now 50 plus this, because the gas from here is getting through here. Now the gas is occupying all this vacuum, all this place volume. So thereby V plus 50 liters is the total volume occupied by the given gas, and thereby decreasing the pressure. Now it is occupying more space, no? So it decreases the pressure. Constant temperature, we know one formulation here, P1 V1 by T1 equals to P2 V2 by T2. Okay, temperature constant, I'm cutting this off. So I will substitute my P1 V1. What is that? Pressure is 21 into 50 liters is equal to pressure 2 is 7 times 50 plus V. So now go on with this calculations, 150. And here this will be 150 minus 50 is your 100 liters. 50 plus V implies 100 is your volume. So 100 is the volume of this big tank, what we are talking about. All right. Moving on with the next question there, question number 3. Any doubt, you may please let me know in class tomorrow. Next. Number 3. Let's go with number 3. At constant temperature. Okay. At constant temperature, they said, what should be the percentage increase? Percentage increase in pressure for 5% decrease in volume. 5% decrease in volume. What is the increase in the pressure at constant temperature? That is what we are talking about. So let me talk about the cases here. So initially the pressure, I don't know. This is P, this is P dash, I would say. And initially the volume was V. Now 5% decrease in the volume. 5% decrease in the volume will be 95% volume only now. 95% volume is 95 V by 100. Which is, when I cut it down, 19 V by 20 is my new volume here. P dash is P, the new pressure is P dash. How much will be the increase in the pressure at constant temperature? We have the formulation P1 V1 equals to P2 V2. So I would say P1 as P and V1 as V equals to. This is my first case and here is my second case. So second case, P2 will be my P dash and V2 will be my V dash, right? And in the place of V dash, I can use here this one, 19V by 20. Now PV is equal to this, cuts off. Now my P dash is equal to 20P by 19. This is my P dash. Now the question is, how much is the pressure increased? How much percent is the pressure increased? Percentage change is always, you have done it in your 7th standard. Percentage change is always change by the original multiplied by 100%. How much is the change now? The change is P dash minus P, which means 20P by 19 minus P, which will be, how much is that? divided by 19 and 19, I take 20p minus 19p, which is 1p by 19. So now let me go with using this. Change is my p by 19 by original. Original is my p times 100%. So now this would be 100 by 19%, whatever that answer is. That is somewhere around 5 point something, 5.26% what we got. So here is my change in the pressure. Change in the pressure asked to you. So first bring out the change, which means P2 minus P1 or P dash minus P. How much is that? The final pressure minus the initial pressure. So that divided by the original pressure you will do. All right. So that would be the question number 3 here. Next, moving on to question number 4. Yes. Number 4, at constant pressure. So at constant pressure, this time it is constant pressure. Constant pressure implies that's the Charles law. Charles law happens to be at your constant pressure. V1 by T1 is equal to V2 by T2. Or you can just, you don't need to remember this also. You simply write P1 V1 by N1 T1 equals to P2 V2 by N2 T2. It's the same amount of gas we are talking about. Number of moles are not changing. Charles law at constant pressure, they said pressure, remove that because that will be anyway get cancelled. So P1 by T1 is equal to V2. V1 by T1 equals to V2 by T2. Now, my question is, at a constant pressure, what should be the percentage? How much percentage increase in temperature in Kelvin for a 10% increase in volume? That is what is being asked, a 10% increase in the volume. So two cases, first case and second case as usual. So constant pressure, P is the same here, and temperature. So how much is the temperature? I don't know that. So T1, T here and T dash here. Okay, here the temperature is T, there the temperature is T dash. And percentage increase in the volume. Original volume is V. Now there is a 10% increase in the volume, matlab V plus 10% of V, which is V plus 10 by 100 of V, which is 110 V by 100, which is 11 V by 10. This is my V2. This is my V2. So this is my V1, V2. So now V1 by T1 equals to V2 by T2. Let us apply that. V1 is V by T1 is T is equal to V2. What is the V2 here we got? V2 is my 11V by 10 by T2 that we do not know. This V cancels off with that. T2 is equal to 11T by 10. That's what we got, T2. Now, how much is the change in the temperature? So, temperature percent, delta temperature is change by original multiplied by 100%. What is the change here? Let us talk about change. Change is T2 minus T1. T2 is 11, T by 10 minus T1 is T itself. So here LCM again. This is 11T minus 10T, 1T, T by 10 it is. So now change is my T by 10 by the original is T times 100%. So here, as you cut down these things, 10% is the temperature change, increase in the temperature noticed. That would be the answer here. Next, moving on to the next question. Any doubts in this? Please do come back to me tomorrow morning as you see this. All right? Yes. Next, move on to the next question. Coming up to that, next, according to the Charles law, you are given some things here. Options are given to you. I'm not right now giving the options. Charles law. Charles law is at constant pressure, volume and temperature, how are they related? More the volume, more the temperature. So volume is directly proportional to temperature. So V is equal to KT. So V by T is equal to K, which means change in the volume by change in the temperature, which means dV by dt at the constant pressure is constant. That is what is your option A here. This is option A. You have four options given to you differently, so option A you would choose here. Next, question number 6. Moving on to the next one, question number 6. Volume of the gas is 100 ml. You're given 100 ml at 100 degrees Celsius. If the pressure remains the same, then at what temperature, will it be 200 ml? 200 ml. So always define them. So this is V1 and this is T1. And T1, please notice that you will never accept anything of temperature in degrees Celsius. You will always go with your Kelvin scale, which is 100 plus 273. Exactly speaking, you have to go with 273.15 also, but for easy calculations, I'm going you with this. So now this is 373 Kelvin. That is your T1, and you have V2 is T2, how much? So V1 by T1 equals to V2 by T2, or in case you don't remember this, I want you to remember this, but yeah, in case. So P1 V1 by N1 T1 equals to P2 V2 by N2 T2. Here we are not changing the moles of the gas and we are not changing the pressure. So hence I am left out with V1 by T1 equals to V2 by T2. Now just substitute the values. V1 is 100 ml by T1 is 373 is equal to V2 is 200 ml by T2. Now here your temperature you should definitely change, but your volume you need not change that in liters, because both the sides, as you change it into liters, you will be anyway dividing with 1000 on both the sides, which will anyway nullify the things there. So now my T2 is equal to 373 times 2. So whatever that answer is, that you're going to get in Kelvin, right? 746 Kelvin, but the answer is in Celsius given to you here. So 746 minus 273 Kelvin. So that is what you're going to get as 473 Kelvin here. That will be your answer, option B here. All right. Yes. So if you are, if I'm going a little fast, please pause it and you try it along with yourself and then you let me know. Next, then you can go on directly. Yes. Moving on. Next, coming up with the next question, question number 7. A gas cylinder containing cooking gas can withstand a pressure of 14.9 atmospheres. It can withstand, this is the limit. This is the limit that this gas cylinder can withstand. The pressure gauge of the cylinder indicates 12 atm. Whenever you have two different cases, please write it down in two different cases. Okay, now the pressure gauge in the cylinder indicates 12 atm at 27 degrees Celsius. And what do you mean by 27 degrees Celsius? As I told you, never ever accept anything in degrees Celsius. Please convert it into your Kelvin scale. 27 plus, how much is that? 273. So that is going to be my 300 Kelvin here. Due to the sudden fire in the building, the temperature starts rising. The temperature at which the cylinder will explode is, what is this temperature at which it is reaching the maximum limit of the maximum pressure, right? That is what it has been asked to us, and volume remaining the same here because the cylinder volume, where as it bursts till that time, the volume is going to remain as the same. So now it is the relation between pressure and temperature, right? So P1 V1 by T1 equals to P2 V2 by T2. Here my volume is the same. I'm cutting down my volume. Now what is my P1? 14.9 by T1. I do not know. Is equal to P2. P2 is 12 atmospheres by 300 temperature. So T1 equals to 14.9 times 300 by 12. That gives you the answer. All right. So that is somewhere around, as you can see, you will get it in Kelvin, and Kelvin minus 273, you will get it in the Celsius. The answer would be 99.5 degrees Celsius. Please do the calculations and let me know if you got the same. Next. Next question you have flasks A and B of equal size. Flask A and flask B equal size, which means volumes are same. Okay, then it contains 2 grams of hydrogen and here 2 grams of nitrogen respectively at the same temperature also. Time temperature also is same now. Now the number of molecules in flask A is same again. So P1 V1 by T1 equals to P2 V2 by T2. So now the pressure also remaining the same. So if you check out here 2 grams, let us bring out the number of moles here, right? So number of moles, how much will be the number of moles? Given mass by molar mass. Given mass is 1 by the molar mass is 2. Here given mass is 2 by 2, which is my 1 is the number of moles of hydrogen and given mass by molar mass. Nitrogen stands with 14 mass, 14 twos are 28. So this is 1 by 14. 1 by 14 is for the nitrogen mass. So now as you go on with your putting your relation there, coming back, yeah. So here number of moles here of hydrogen is 1 and number of moles of nitrogen is 1 by 14. Obviously, flask 1 has got more number of moles. No relation here imparted required because it is talking about the number of moles in a closed vessel. So that is what it is. So find the number of moles. That's it. Will give you the answer there. Okay. So will be greater. The first one will be greater than the second one. That's it. Next, moving on to the next question. Yeah. Here the question talks about question number 9. Yeah. Number 9, 3.2 grams of sulfur on heating occupies a volume of 780 ml at 450 degrees Celsius and 723 mm pressure. Formula of the sulfur is, I want the formula of the sulfur. So we don't know that. So let us talk about PV equals to nRT, right? So PV equals to nRT. Now pressure is 723 mm is given to us. But I know that it for the constant, for the standard temperature and pressure always has to be in APM and volume in liters. So volume in liters, this would be my 780 by 1000 liters. This I get. And 760 mm is 1 atmospheric pressure. So 723 mm is how many atmospheric pressures? So because that is what we want. So now just have to cross multiply 723 upon 760. Now PV is equal to nRT. I'll directly apply. In the place of P, it is 723 by 760 times volume is 780 by 1000. That is the volume we have is equal to nRT. N stands for your number of moles. Number of moles is given mass by molar mass. Given mass is 3.2 by molar mass. I do not know. And my R value is 0.0821 times my temperature here. Do not accept temperature as 450. It is 273 plus 450. So that is what is going to be your 723, right? 723 is my Kelvin there. So that is my temperature in this Kelvin. So now find out the molar mass for this. So molar mass I get, and that would be my answer there. Molar mass, whatever I get, and divided by your sulfur mass 32 will give me the molecular formula. So somewhere around molar mass, as you calculate this, all of this, C 723 will go off. So like this, if you calculate 0.0821, I prefer you taking it as 1 by 12 because that can be easily cut out also. So as you do that, you will get somewhere as 256 as your molar mass, closely around 256. Now the molecule for it, molecular formula for it is molar mass by the atomicity, right? Or molar mass by the each atom mass. Molar mass by 32, matlab 256 by 32, somewhere around, yes, 8 this is. So sulfur molecule formula is S8, is the volume of is the molecule of the sulfur. That is what we can go. And then question number 10, moving on with question number 10. Volume of the balloon filled with 4 grams of helium at 22 degrees Celsius and 720 mm of Hg. What is the volume of this helium? It has been telling to you. So PV equals to nRT, our ideal gas equation. Let us do that. So pressure is 720 mm of Hg. I will convert it because 720 is how much pressure? If 760 mm is 1 atm, please convert it. So now as you cross multiply, pressure is 720 by 760 cross multiplication times V, volume, and that is what is being asked to us, is equal to N, stands for the number of moles. The number of moles is given mass by molar mass. Given mass is 4 by molar masses. For helium, molar mass is 4 times R is 0.0821, or I can simply take it as 1 by 12 also. In case my answers are not very close to each other, then you can take it as 1 by 12. Otherwise, if they are close to each other, no other option, 0.0821 you have to take. And then temperature given to me here as 22 degrees Celsius, it is 273 plus 22. Don't forget this calculations. So that would be 295 Kelvin. So here the only unknown term here left with you is your volume. You would get your volume here there. All right. So please convert it, check that out, and let me know what is that you got. And if you don't get the answer right, then come to me tomorrow for your clarifications without fail. All right. And bring out your workbook also. I want to see the worksheets as well, workouts as well. Yes. Moving on to the question number 11 now. Yes. Number 11, what it says, two containers A and B contain the same gas. Okay, I'm writing it as same gas. And if the pressure, volume, and the absolute temperature of the gas A is twice as compared to that of in gas B. So gas B, if I take pressure, volume and absolute temperature. See, I'm reading out the question again. If the pressure, volume and the absolute temperature of the gas A is twice B. See, gas A is twice B, it says. So which means A is equal to 2 times B. So I'm taking B as this P, V and T. So my A will be 2 times pressure, 2 times volume and my 2 times temperature. And also it is being said that if the mass of the gas B is X grams, gas B is X grams, the mass of gas A will be how much? Here mass is how much? So let me use the same thing again, same gas it is saying us. So P1 V1 by N1 T1 equals to P2 V2 by N2 T2. So P1 will be my 2P into 2V by N1, number of moles, I don't know. Number of moles is given mass by molar mass. Given mass, I don't know, let that be some Y I am taking. Okay, some given mass by molar mass, I don't know, MR also, because the which gas is not given to us, times temperature is 2 times T is equal to P2. P2 will be P, V2 will be V, by N2. N is nothing but N stands for number of moles, given mass by molar mass. Given mass in the second condition is your X grams by molar mass MR times T2. Temperature is T. Now, as all these things to the other side, PP gets cancelled, VV gets cancelled, T gets cancelled, molar mass gets cancelled, then I am talking about Y here. So Y is here, 2 and 2 gets cancelled. I am left out with numerator mein 2 by Y is equal to, how much is that? 1 upon X. So implies Y is equal to 2X. That is my option, 2X grams. In terms of grams, in terms of X, they asked us, so we brought it out. This is option D. Okay. Next, we just have simply written what is the conditions given to us, and we are just applying the same formula. P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Just blindly apply that. Yeah. Next, question number 12. What is the final temperature of the sample? I'm reading the question and writing the information. Right. What is the final temperature? T final temperature of the sample of ammonia gas. NH3 is the gas. Initially, at 3 atmospheres pressure. This is initial. Okay, initially at 3 atmospheric pressure at a temperature of 500 Kelvin and a volume of 275 liters is changed to volume 200 liters and a pressure of 2.5 atm. So T2 is how much? They are same again. P1 V1 by N1 T1 equals to P2 V2 by N2 T2. Here, temperature is being asked to me, and I'll just have to substitute the values. That's it. Yeah, P1 is 3 atms times V1 is 275 liters by N1. N1 is your number of moles, and it is the same gas we are talking about. So I don't need to consider my N here. Number of moles gets cancelled, same amount of this. And T1 is at 500 Kelvin in the first case is equal to P2. Pressure is 2.5 atm. V2 is 200 liters. Make sure everything is in proper units by T2. That is being asked to me. From here, you can bring it out. That's it. Just cross multiply and bring out the values. I'm not doing the calculative part of this. Next, I'm moving on with the next question. 5.4 grams of unknown gas, some gas, I don't know what that gas is about, and that occupies 27 degrees Celsius, and Celsius aate hi, do not consider that Celsius at all for any of your calculations right then and there. Whenever you write, convert it. So that would be 27 plus 273, which will be my 300 Kelvin is my temperature there. Now, I'm reading out the question again. 5.4 grams of an unknown gas at 27 degrees Celsius occupy the same volume, as 0.14 grams of hydrogen at 17 degrees Celsius and same pressure. The molecular weight of the unknown gas is. So same again, P1 V1 by N1 T1 equals to P2 V2 by N2 T2, right? So P1 V1 by N1 T1 equals to P2 V2 by N2 T2. Same volume they said. Please consider that same volume. I'm cutting down the volume there. Same pressure also they said. So same pressure also gets cancelled. Thereby N1 T1 equals to N2 T2. Cross multiply there. Yeah. Now N1, number of moles of the gas. Number of moles I don't know. Given mass by molar mass. Given mass is 5.4 for the first. By molar mass I do not know. Into temperature for the first set is 300 Kelvin is equal to N2. Second gas is hydrogen. Given mass is 0.14. By hydrogen is molar mass 2. Given mass by molar mass N stands for the number of moles. Times 17 degrees. Don't accept this 17 also. That is 273 plus 17, which will be 290 Kelvin. 290 Kelvin. Here, the only unknown left out with you is your molar mass. That's it. Now you will get your answer. Cross multiply, bring out the molar mass. That will be your answer there. Yes, so I am moving on with the next question very quickly. Pause it up and do the calculations, and you will show me the answer as you come out tomorrow, right? Then next, please do the calculations, bache. Do not use your calculators as you are at home. Okay, I don't want you to use the calculators at home. here in class, we can use calculators to do number of questions, but there, as you do your own practice at home, I want you to do practice with your numbers very well, because that will gain your speed. Next. Moving on, yeah, going on with the next question. Which of the following gases would have largest density? Okay, largest density at 25 degrees Celsius and 1 atmospheric pressure. Options are given to you here. I'll give you options here for this. CH4, then acetylene. Acetylene is C2H2, bacha. This is acetylene, okay, which is C2H2. This is two carbons with triple bond. And ethylene is C2H4, double bond, C double bond C, okay, C2H4. And propane. These are your options. Largest density. Now, what do you mean by density? Density is PMR by RT, right? Right? Because see, we have already seen that, we have already calculated that ideal gas equation PV is equal to nRT. We know P times V, N is equal to given mass, I don't know that, by molar mass, given mass by molar mass into RT. Now, if I say this and this, okay, you bring it on to the other side. X by V is equal to PMR by RT. Whatever that X is, given mass by volume. Mass by volume is density, right? Density is mass by volume. See here, they said at the given pressure and given temperature. So pressure and temperature here doesn't have any sense, right? At the pressure given, temperature given, and at my R also. R also is the same thing. That also will not change. Now, which of the following will have largest density? Whoever is having the larger molar mass. Larger molar mass kisko hai? Propane is what? Propane is my C3H8. So definitely larger molar mass for C3H8 as compared to all of them, right? That is CH4, C2H2, C2H4 and C3H8. Obviously, C3H8 has got molar mass more, because your density is directly related with your molar mass. More the molar mass, more is the density. So that would be your answer there. Next, question number 15. Let's move on with the next question. Yeah. Question number 15. To expel half the mass of air from a large flask, okay, there is a large flask at 27 degrees Celsius. It must be heated to what temperature to expel half of the mass? So what do you mean by that? To expel half of the mass, please try to understand what is happening here. You are having a open dish. It is not a closed one. So something is getting evaporated. It is going out. So volume of the container is the same. Here the volume is the same. See, P1 V1 by N1 T1 equals to P2 V2 by N2 T2. I would say, since it is an open vessel, my pressure is same, 1 atmospheric pressure as it is open vessel. Why is that open vessel? Question did not say that it is open vessel, but I am considering it to be my open vessel because something is being expelled out, which means it has to be open at the top, right? And I would say volume is also same, because volume of a gas is always the volume of the container, not dependent on the number of moles. So how much ever number of moles is, those particular number of moles will occupy the same volume of the container. Whether I bring a gas of 10 ml or a gas of 100 ml or a gas of 1000 ml, if I leave it in a room of 10,000 capacity, it will take up my 10,000 capacity only. So nothing here is dependent. My volume here, number of mass is not dependent on the volume here. This is independent. So here it is N1 T1 because it is a gas equals to N2 T2. Now number of moles is given mass by molar mass. Given mass, molar mass is anyway same. Molar mass also gets cancelled. Now the first one is originally X grams if I have. Now here it is X by 2 grams. temperature T1 is 27 degrees Celsius. I don't know what that is. 27 degrees Celsius is what? Please do not consider degrees Celsius. It is 27 plus 273, which is my 300 Kelvin. So put it as 300 here, is equal to T2. That is what is being asked to us. This cut off 600 is my T2. 600 Kelvin is my T2. In case your answer is in Celsius, please convert it back to Celsius. 600 minus 273 degrees Celsius is what your answer would be. Next, moving on to the next question, question number 16. Now it says open vessel. Oh yeah, again on open vessel. Open vessel implies atmospheric pressure is 1, which is constant pressure. So now I'm reading the question back again. An open vessel containing air is heated from 300 Kelvin to 400 Kelvin. So this is my T1, that is my T2. The fraction of air originally present which goes out of it is, how much is the fraction of air originally present and how much is that it is going out? We don't know that. Let's go with the same formulation again here. See P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. My atmospheric pressure is the same, so pressure I am cutting off, and the same burden, the same vessel I am using, so volume also is the same. I will cut off that also. So N1 T1 equals to N2 T2. Originally, it is like number of moles, I don't know. Let that be some N1 only. I don't know that because it is nothing is given to us. So let that be N1 only, and T1 is 300 Kelvin is equal to N2 times, and this is 400 Kelvin. So 3 by 4 times N1 is equal to my N2. So N2 is only 3/4 of N1 left out, which means 1/4 of it is being expelled out. How much of it is expelled out is the question. How much is expelled out? Only 1/4 of it expelled out. Please don't write it as 3 by 4. N2 is equal to 3 by 4 of N1. N2, how much is the N2 remaining with me? It is 3/4 of the N1 is remaining with me. So which means 1/4 of it is expelled out. That is my answer, 1/4. Not 3/4. So these are the numbers which may trick you a little. So please be very cautious there. Next question, question number 17. Now, let's write the information again. I'm reading out the question and writing the information. Carefully do the same. 0.2 moles of a sample of hydrocarbon CXHY yields after complete combustion with excess of oxygen gas, 0.8 moles of CO2 plus 1 mole of H2O. CO2 ke niche I would write it as 0.8 moles given to me, and water molecule is 1 mole given to me, and here is 0.2 moles. I would just write it down here. Yeah. Now hence the hydrocarbon is, you're given options here, C4H10, then C8 C4H8, then you have C4H5, then you have C8H16. Yes. So let us first balance this also. So this is CXHY. So let this be here X then. And Y times hydrogen you have. So this has to be Y by 2. So how many oxygen here on my right side? Oxygen is 2x here. As you see, 2x plus Y by 2 is my oxygen on my right side. So left side here, it has to be 2x plus Y by 2 upon 2, which is x plus y by 4 I should get. And why am I getting this? See, in case, try to imagine that in case I want 5 oxygen on the right side, so I have to write here as 5 by 2. If in case I want 10 oxygen on the right side, I will write 5 here, which is nothing but 10 by 2. In case I want 11 oxygen on the right side, I will have to write it as 11 by 2 times 2, right? Which is 11. So whatever I want, this star bracket is that or what I want. So bracket by 2, which is nothing but x plus y by 4 is what I have written, right? Now, hence, which is the hydrocarbon is being asked to us. So let us put that in the stoichiometry relations. Same thing we will go with. So this is the moles given to me, and 1 mole of it is given to you as this is 1x 1a mole. I will write this molar ratio as this is 1a, this is this much a, this is xa, and this is y by 2a. So 1a is equal to 1a is equal to 0.2 moles. And here is my xa. xa, which means x times 0.2 is equal to 0.8 moles. So x I'm getting as 0.8 by 0.2, which is 4. So 4 is what I have the option. 1, 2, 3 options I have already. Chalo, then this is my y by 2 times a. So y by 2 times a is 0.2, is my 1 mole. So y is equal to 2 by 0.2. Right, 0.2, I would write it as into 10 into 10. This is my 2 and 2, 10. So this is my C4H10. That's my answer. This is nothing related to your this part. Yeah, you could have done it in gaseous state methods as well, but it is a little long, but you use stoichiometry, then it becomes very easy. These type of questions, we have done so many questions on CXHY balancing part. So this balancing is very, very, very important because this comes generally in your combustion reactions the same way. So go for it, pause it up, go back. If you don't understand, go back, again do it. Still don't understand, please get it to me the next day so that I will clarify you the next day. Okay, then next question number 18. If the pressure of a given mass of a gas is reduced to half, so originally the pressure is P, now it is P by 2. And the temperature is doubled. Originally it is T, now it is 2T. See, according to the question, I'm writing the information like this. Pressure of the given mass of the gas is reduced to half and the temperature is doubled simultaneously, then the volume will be water. So originally it is V, so how much will be my V dash? Same thing again, P1 V1 by N1 T1 equals to P2 V2 by N2 T2. It is a closed one, so number of moles will remain the same, no change there. So in the place of P, P1 is P times V1 is V by T1 is T is equal to, now P2 will be my P by 2 times V2 will be my V dash, I don't know that, by T2, T2 is my 2T. So pressure gets off, temperature gets off. So this is 4 times V is your V dash, right? So that is what you get. And next, the option is not here, same as before, twice as before, 1/4 as before, but this is quadrupled pressure, volume is quadrupled as before, none of the above is your answer there. Next question number 19. 1 mole of an ideal gas, 1 mole, I'm writing the information, 1 mole of an ideal gas A, ideal gas A with a 300 mm of Hg, that is my pressure given to me, is separated by 2 moles of another ideal gas B with 300 mm of Hg in a closed container at the same temperature. If the separation is removed, now initially it was like separated, these two were separated. Now if the separation is removed, then the total pressure is how much? Now the total pressure is how much? How much is the total pressure given to us? So now let us convert everything here. If everything is in units, please be careful about the units also. So here we talk about something called as Dalton's law of partial pressures, which means if I have like this, a can wherein I have 2 gases. Okay, so initially the gas 1 is being separated out with gas 2, okay, with some membrane there, and 300 is the pure pressure of A, and 300 is the pure pressure of B as well. Both of them are the pure pressures of A and B. So how much is depending on how much fraction you're getting, because that depends on the Xi. Xi stands for the mole fraction. Xi A is equal to number of moles of A by total moles. And similarly, Xi B will be number of moles of B by total moles. So first talk about Xi A. Number of moles of A given to us as 1 mole. By the total moles is 1 plus 2 here, 2 moles here, 1 mole there. So 1 plus 2, 3 moles. And here will be 2 by 3 moles, right? Now, my pressure exerted by A will be my nothing but Xi A times your pure pressure of A, which is 1 by 3 times pure pressure of A is 300 if only that element is existing there. And similarly, PB will be Xi B times P naught B. Xi B is 2 by 3 times P naught of B is 300 given to us. This will be my 200. Now my total pressure exerted by it is PA plus PB, which is 100 plus 200, which is 300 mm of Hg. Here I am not converting mm of Hg. I am not converting because whatever you convert, you'll be anyway lining up on the right side and left side, cancelling each other. So I'm not converting that here. All right, so there comes end with the question number 19 there. Moving on to the next question. So total is 300 only. Okay, don't just add it like 300 plus 300, 600. No, it is total 300 only atmospheric pressure now. Now, coming up with question number 20 here. Assume center of sun to the consist gas whose average molecular weight, molar mass is 2, and then density is given to you and pressure is given to you. Density of the gases as 1.3 grams per centimeter cube is given to me, and the pressure is 1.12 times 10 to the power 9 atmospheres given to me. The temperature of the sun is how much asked to us. So what is the density relation? Density is equal to Pm by RT, right? That comes from the ideal gas equation. We have just now derived it. So density is equal to Pm by RT. Pressure is given to you in ATM, which is fine, good enough. And this one, 1.3 gram per centimeter cube. Please convert this gram per centimeter cube to kilogram per meter cube first. So this is 1300 into 1000 you will do kilogram per meter cube. That is 1300 kilogram for 1 meter cube it is, right? Now, I want this to be in my densities and this has to be my meter cube has to be in liters, right? So 1 meter cube and 1 decimeter cube. See, 1 liter is 1 decimeter cube, dm cube. I would say 1 liter is 1 dm cube. So please convert that first. Meter to decimeter. Meter to decimeter, you would just have to multiply with a 10 there, right? Meter to decimeter. Multiply with 10. Meter cube to decimeter cube, you will multiply with 10 cube dm cube, which means nothing but 1.3 liters. Again, this kg per liter, because 10 cube decimeter cubes is 10 cube liters. 10 cube ante 1300 by 10 cube, it is 1.3 kg per liter. Now, because why am I changing everything? Because I want it the pressure to be in atmospheres and volume to be in liters only for this, right? Now go with the pressure, which is 1.12 into 10 to the power 9 into the molar mass, which is being 2 given to us by R. R is 0.0821, or you can take it as 1 by 12 as well, times the temperature here. and temperature is being asked to me, and that is my density, which is 1.3. Now bring this temperature to the other side, 1.3 to the left side, and everything gets cancelled. You can just do the calculation and tell me the answer tomorrow. Bring that workout tomorrow to me. Next, 21. Go on with the next question, 21. One second. All right. Yes. Now 21, 6 grams each of the following gases. 6 grams each at we have the following gases here given something. 6 grams each of the following gases at 87 degrees Celsius and 750 mm pressure are taken. Which of them will have least volume? Least volume will be occupied by what? How do we compare? So we are given here the temperature, and also we know PV is equal to nRT. Okay, so V is equal to nRT by P, right? Everything is the same temperature and same pressures, right? So what is that dependent on? 6 grams is given to you, right? So number of moles is given mass X by molar mass. I'll write RT by pressure, that is the volume. Okay, least volume for greater molar mass, agree? Because everywhere, because this is 6 grams, right? So 6 grams is given mass, everywhere the same thing, everywhere R is same, everywhere the temperature is same, 87 degrees temperature is given to us, that is also same, and pressure also is 760 mm for all the 4 options given to us. Options here, I didn't give you the options here. Let me give you the options also here. Options A, B, C, D here given to us as HF, HCl, HBr, and HI. 4 options are given to you. Which one of this has got least volume under these conditions? Everywhere the same conditions. So all of it is the same except the molar mass. So volume more, the molar mass has to be the least, because volume and molar mass are inversely proportional to each other here. As you can see, something divided by molar mass division, as you divide with a greater number, you will get the least value. So whichever has got the maximum molar mass, I would say hydrogen iodide is the answer for this. Maximum molar mass, least volume, definitely, right? Because you're dividing with a greater number, you will get the least volume there. So HI out of all these things, because FCl, BRI, they are all halogens, halides. As you come down in the group, halogens everywhere, whatever you see, as you come down in the group, mass increases. So iodine mass is more. So HI is more. So more HI for least volume there. Then moving on to the next question there, next 22. Now, density of the oxygen gas is, density of oxygen is 1.458 gram per liter. Gram per liter it is given. So gram per liter, that is what my comfortable unit, liter, very fine. Density of this is gram per liter. Once again, yeah. At 25 degrees Celsius given to me, and do not accept that as Celsius, that is 27, 25 plus 273, right? That will be 298 Kelvin to be used there. And 1 atmospheric pressure, 1 atm pressure. Next, it says at what pressure will O2 have the density twice the value? Okay, which means density of B will be 2 times density of A. That is what it is saying. Second case density. It is asking again, I'm giving you the question back again. Density of oxygen gas at 25 degrees Celsius is 1.458 gram per liter. At 1 atmospheric pressure, at what pressure will O2 have density twice the density of the value of the A? So density of B is equal to 2 times the density of the A. And what is the density formulation? Density is equal to PMR by RT. MR, PM by RT you say, but MR I say because MR stands for molar mass, right? So pressure of the B into molar mass. Molar mass will be the same, right? By R into time in the B part is equal to 2 times pressure in the A part, molar mass by R into T in the A part. So as you can see, R gets cancelled, molar mass also gets cancelled. Temperature in the second part. What will be the temperature in the second part? That is what is being asked to us, or what? One second, let me read out the question. Yeah, so we are not given anything about that also. Second, let me switch on my. Oh, yeah. Sorry. Yes.